So we're going to talk about 3D geometry, and specifically we're just going to talk about some of the vocabulary involved, and then we get to practice applying some of those vocabulary with the practice sets. The first thing I want to talk about is, well, first of all, we start learning about two-dimensional shapes, right? So now we're moving on to three-dimensional shapes, and one of the basic three-dimensional shapes we talk about is a prism. And a lot of times we'll see something that's like a rectangular prism, right? That's a box, but the fancy geometry word for it is a rectangular prism. And then we might also see a shape where the top and the bottom are some other shape other than a rectangle or square, and we'll call that prism based on what the shape is. So this next shape here is a hexagonal prism because the ends are hexagon. So the key characteristics of a prism are that they are three-dimensional objects, and the two flat ends are exactly the same. So in both of these, you can see the rectangular prism, the top and the bottom are both the same shape, and they're parallel to each other. We'll talk about what that means in a little bit too. And all the sides are flat. And then once we get into a shape like this, of course, when it comes to circles, shapes start having their special names, like a cylinder. When the ends are circles, we call it a cylinder. Now, a pyramid is, I know you know what a pyramid is, but we can have a pyramid with all different types of bottoms, right? So here, this one is a square pyramid, and that's probably like a pyramid you've seen before. But the shape could be any shape, really. Here's a triangular pyramid. And then, of course, when it becomes a circle at the bottom, we have a special name. We call that a cone. So the sides are triangles that meet at the top, and the base is some kind of flat shape. And so we name the pyramid based on whatever that shape is. That bottom part of the pyramid, or the top and the bottom part of the prisms, we call the bases. So here at the top, you can see a triangular pyramid has a base that's a triangle, a cone has a base that's a circle, and a square pyramid has a base that's a square. And then we have three prisms, one that has a base that has bases, that's again the top and the bottom, that are hexagons. And the next one is a rectangular prism, so the top and the bottom are rectangles. And then the cylinder has a top and a bottom base that are circles. The next thing we're going to do once we have identified these three-dimensional shapes is talk about their parts. So we just talked about the bases, but we're also going to talk about all of the lines that make up the shapes. So here we want to talk about sets of parallel lines, and when you do identify a line, for example in this first figure, that's a triangular prism, the two lines highlighted we would call HG and KJ, or GH and JK. But you need to name the 2 points on the line in order to identify it. So when we're talking about parallel lines, they of course are lines that go in the same direction and they never intersect, right? And we say that they're in the same plane, and we'll talk about what that means in a little bit. But here we have 3 different examples of parallel lines. They're going kind of in the same direction and they never intersect. You might, though, talk about intersecting lines. So these lines are, of course, actually do meet at one single point. And here are a few examples of lines that meet at one single point. Here, a third type of set of lines are called skew lines. So these lines are not parallel. They do not intersect. However, you can see that they're going in different directions. They're not on the same side of the shape, but even though they never intersect, they are not parallel. So I've said that word plane before, and what a plane is a two-dimensional area. In geometry anyways, we call it a two-dimensional area that has no thickness but goes on forever. Now, even though the top side of this cube or square prism has a defined area, it doesn't go on forever and ever. That defined area is on a plane. It's part of a plane that does go on forever and ever. So we could identify this plane by at least three different points. So we're going to call the plane IHG or FGH or IFH. All you need is 3 points to identify a plane. And so any 3 points that are on this blue plane would identify it. So then just like lines, we can talk about parallel planes. Those are planes that never intersect, never cross each other. So you can see that the top and the bottom of this cube, this plane FHI and this plane EBC, they will never touch each other. If you can imagine drawing a straight line on the top of a box and a straight line on the bottom of a box, or holding a ruler across the top and a ruler across the bottom, you would notice that they would never intersect. Those planes never intersect. They're going in the same direction. They're like on top of each other. But you might have two planes that do intersect. So here's an example. CDH is that blue plane and EDH is that yellow plane, and they share that one line in common. That DH line is where they cross. So it's like the two sides of the cube have one corner or edge that they share. And so those two planes are considered intersecting planes.